Okay, so example one, now that we know that we're either, when we have an absolute value with an inequality, we're either most likely going to have a disjunction or a conjunction. By the way, just a little bit of review of what it means to have a disjunction or an intersection of sets, and, or a union of sets, sorry, or a conjunction, which is the intersection of sets, is that it's a logical, for conjunction and intersection, it's a logical and for disjunction or union, it's a logical or. So just like when we were doing the interval notation, the union symbol for intervals, as opposed to the in set builder, it was the word or. That is the same thing here. So like when you have two separate pieces to it, it's going to be an or. When you just have one set, it's technically an and, where you're looking for the intersection of the sets or where they overlap, and they will overlap in the middle between two values. So let's get to some problems. Now I'm going to show you both methods, and I know a lot of you guys prefer doing the algebraic method, so I will start with that. But I also want to show you the conceptual method because it is by far the easiest, I think. If I'm going to do it algebraically, you first have to determine whether it's an and or an or statement, a disjunction or a conjunction, or if you want to say intersection or a union. In this case, the absolute value is less than 30. So right here is less than 30. If the absolute value is less than some set value, I know that this is going to be an intersection or an and. So what I'm going to do, if I'm going to do it algebraically, let's pick a color, like maybe green. It's going to be technically the word and in between. And we're going to have the positive version and the negative version. Now you have to be really careful when you do this, because you can't willy-nilly just make, the positive is pretty straightforward. It's going to be 3x minus 6 is less than 30. But on the other piece, you cannot just say, oh, 3x minus 6 is less than negative 30. That's not true, because essentially you're multiplying by -1 on both sides. So I tend to do it this way. I'm saying whatever's inside the absolute value, the positive version has to be less than 30, and the negative of what's inside, when I take the absolute value of that, will also be less than 30. So I'm going to write negative of 30x minus 6 is less than 30. And then I just solve each of them algebraically. And because it's an and, technically I'm supposed to look for where they intersect. So in this case, I have 3x is less than 36. X is less than 12. And over here, divide both sides by -1, I get 3x minus 6 is greater than -30. So in this particular case, you may have been taught this before, where they say just switch the sign and make it negative or something like that. This is the algebraic reason why you have to switch the sign over on the other side. All right, so now we're solving. So we get 3x is greater than, what do we get here? -24. So x is greater than -8. And because it's an and, I need to find where those two sets intersect. So I'm just going to put a 0 here in the middle, -8. It doesn't have to be accurate, the drawing. We're just sketching it out to get an idea. So we have 12. Notice that I'm not putting the graph on the number line. I'm just putting it above, that's the one set, and the other set is greater than -8. I'm looking for, it's the word and, so I'm looking for where they intersect. That's where they have common points. It's all the points that are on both of them at the same time. So it has to be both greater than -8 and at the same time be less than 12. So that's why these here are going to be our values, like that. So in interval notation, it's going from -8 to 12. If I did set builder, it would be x such that -8 is less than x, which is less than 12. Now, the other option is this. If you know, because it's a less than, it's an intersection or it's a conjunction, it means that the resulting piece will be an in-between statement. So another option would be to know, and you can only do this for the less than, if the absolute value is less than. It's only true if it's less than. So look, I know that the 3x minus 6 has to be between negative 30 and 30. So down there, so I could write it like that and just do the whole problem in one shot. So, oh, that's really hard to read. Sorry about that. So then I get negative 36 is less than 3x, which is less than, not negative 36. If I need someone to sit here and yell at me. All right, so it's negative 24, sorry. Negative 24 is less than 3x, which is less than 36. And then divide everywhere by 3, I get negative 8 is less than x, which is less than 12. Oh, look, you get the same answer. Now, if I did the same thing conceptually, I'm going to have, by the way, set builder like that. I would rewrite, because I want the leading coefficient to be 1. So here, I'm going to move it over here. Don't worry, I'll erase again. Or maybe I could go down. Maybe I can go down here. I want to rewrite the absolute value where the leading coefficient in front of the x inside the absolute value needs to be either positive or negative 1. So that means I need to divide everywhere by 3. So here, it's going to give me x minus 2 is less than 10. So in terms of the meaning, the distance from 2, oh, you can't see that. There we go. The distance from 2 is less than 10 away. That's really the meaning of it. So here, I'm going to go 10 away on both sides. So that's negative 8 and positive 12 in the other direction. And because we want all the distances that are less than, that's the closest ones, it's going to be all of these pieces in between. Oh, look, we get the same answer, negative 8 to 12. All 3 methods work. The purple one in the middle that I did, that method, only works if the absolute value is less than, but the green and the pink work for either of them. If I do, like, for example, B, however, do you see the absolute value is greater than now, greater than or equal to. You can do it algebraically. When you do it algebraically, you just have to keep in mind that instead of being a conjunction, it's a disjunction. So when we have a disjunction, it's going to be the word or. So it's going to produce 2 separate branches, essentially. And when it's an or statement, we're interested in all of the values that it has or is contained in this set, not just where they intersect, but any branch counts, essentially. So we have the positive, the negative, 2x minus 1 is greater than or equal to 23, or the negative of 2x minus 1 is greater than or equal to 23. And then you solve them each individually, and it's just an or. So the 2 pieces end up in opposite directions here. So we go with 2x is greater than or equal to 24. I almost said 23 again. So x is greater than or equal to 12. And on the other one, okay, divide both sides by negative 1 first, or you could distribute the negative. It doesn't really matter. It's like a stylistic thing. 2x minus 1 is less than or equal to negative 23. Some people skip the first step and just remember to switch a sign and set it equal to, or set it less than or equal to negative 23. Also works. I'm fine with whatever. And in this case, x is less than or equal to, I guess this would be negative 11. And it's an or statement, so everything goes on the number line. We have negative 11, it's inclusive, going to the left. Positive 12 is inclusive, going to the right. If I'm doing set builder, I have to use the word or, so x is less than or equal to negative 11, or x is greater than or equal to 12. If you're doing set builder, you could mention the x is greater than or equal to 12 first, and then say or it's less than or equal to, the order doesn't matter there. But if you used interval notation, it would matter. You would have to, and I'll show you with the conceptual method, I'll use interval notation there just so we practice both. So in this particular case, we have to, if I'm going to use the conceptual method, the leading coefficient inside the absolute value needs to be either positive or negative 1. So I'm going to have to divide everything by 2. So it's going to give me x minus 1/2 is greater than or equal to 23 over 2. And then if I picture the picture, I want the distances that are greater than, like, further away. So it's gonna be on the outside. So I already know what the picture is gonna look like. It's gonna look like this because I want the distances that are far away. So it's going, sorry, I'm looking down because I have my iPad. That's where I'm writing. So it's, even without the numbers, it has to be the distance from 1/2 is 23/2 away, or greater than or equal to 23/2 away on both sides. So 1/2 plus 23/2 is 24/2, which is 12. And 1/2 minus 23/2 is negative 22/2, which is negative 11. Okay, so we get the same thing. It goes from negative infinity to negative 11, union 12 to infinity. And yes, I do expect you to be able to do both versions, both types of notation, interval and set builder. So if you haven't watched that video yet, you need to go back and do that, because my expectations are that you know how to do it. All right, part C you're going to do on your own. I'm just going to put a little note to self here above it. It's the same thing as when we solved equations. You are going to isolate the absolute value first before you do anything else, and then you're going to solve like you normally would with an absolute value inequality. So I'm going to pause the video for a minute. You're going to try this on your own. I'm going to write the answer down. So it's important that you pause the video and then turn it back on so you could check your answer. Okay, I've put up the answer to part C. I also put the note to self NTS on the side. Isolate the absolute value first before you do anything else. And the way I chose to do it is conceptually, because I feel like it's way faster than anything else. So that's where I started with this. It's also going to help me if I'm doing like compound absolute value inequalities, which we're going to do later on. It actually makes finding the solutions to those a lot easier. I just am hoping that you all will start trusting that method instead of getting too bogged down in algebraic manipulation. Sometimes you have to be able to think these solutions out.